Hello everyone, you're most welcome to the Universal Science Scholars Academy, and my name is Master Andrew. So in today's video I want us to be looking at something to deal with the study of periodicity. But before we go and look at the study of periodicity, it is so much prudent that we do realize or rather understand the periodic table before diving into to study things relating with periodicity. So in simple terms, when you look at a periodic table, there are so many things that run into your mind. Most of the learners just look at it as a table that is just having elements in it. But then this table is not just a regular table as everyone does look at it that way. It is something beyond, way beyond a table, and it's something that literally helps someone predict and understand how reactions of elements vary specifically along the periods, or you can also look at them along the groups. So right now I could be saying groups, I could be saying periods, and there is that one person who doesn't know what a table is, also what a periodic table is. But then when you look at this specifically is a periodic table, and in simple terms a periodic table is just a systematic arrangement of all known chemical elements, that is according to their atomic number. All of these elements are basically arranged according to their atomic number, with hydrogen having 1, helium 2, 3 with lithium and whatsoever, ongoing as like it is, as you can see it here. Alright, helium, lithium, beryllium, and all the other elements. So you see that these elements actually are arranged in a way that it helps group the similar properties together. When elements are seen arranged in groups, you get to realize that it is just helping us to study the attributes. It makes literally study and prediction of the behavior of elements specifically in periods and groups so much easier. That's why the periodic table was designed for the scientists to use for study. Alright. So when I've been saying that we're having periods, basically a period is just a horizontal row in a periodic table. For example, when we see here where we are having rubidium, we can have this like this. This is actually a period. So all the horizontal rows in a periodic table, that's what we do call the periods, and there are basically about 7 periods in the modern periodic table. Now, elements are basically classified along these periods specifically because they have the same number of energy levels. Alright, same number of energy levels. Then, for example, when we see the period that runs from here, hydrogen through lithium, like this, these ones all have only one electron shells or one energy level. But then elements that are put under a period have different chemical properties because of the number of electrons that actually seen increasing across a period. Alright, the number of electrons. We do realize that electrons are the ones that are contributing towards formation of bonds that are involved in chemical reactions. So it is so much prudent that you understand that fact. So when you look at a specific period, for example, when you see this specific period, short period 3, we are having sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So looking at them along a period, you realize that in period 3, we are having them actually, all of them are actually occupying period 3, but then they have different characteristics upon reaction. Let's say even just reaction with water. Okay, due to the fact they are having different electrons that are seen. Then when we are to look at a group specifically is now the other, which is the horizontal rows. Let me use another ink specifically. For example, this is a group. This is also a group 1, group 2, okay, and so on and so forth. And in a modern periodic table, there are seen about 18 groups in the modern periodic table. Okay, about 18 groups, not even about, but there are actually 18 groups in the modern periodic table. So these elements, reason as to why we are having elements falling into the same group is basically due to the fact that they have the same number of outermost or rather valency electrons. Alright, when you look at group 1, all of these have the same number. Hydrogen has 1 electron in the outermost, so does lithium, so does sodium, and if we write them out, you realize that it is actually true. For example, when we have hydrogen with a nucleus, we are having it having only 1 electron. When you go to lithium, lithium is 3, we know that we are having the innermost shell having only 2 electrons, and the next shell is having 1 electron inside it. So that is lithium. So common to groups also is not only just having the same number of outermost valence electrons, but then elements that are seen in the same group also have similar chemical properties and reactions. Okay, the way they react with water and all those kind of things is literally the same for all of them. So it is so much for you to understand what the periodic table is all about. So, what I can just tell you about the periodic table in summary is that the periodic table just arranges elements according to the increasing atomic number, like already discussed, and having the periods, which are actually the horizontal row showing the number of electron shells, while the groups are the vertical columns showing the number of valency electrons. So elements are actually placed in periods and groups because their electron arrangements determine the physical properties and the chemical properties. You get the point? We are having them having, for example, when they are put in the same group, meaning that they have similar format of chemical reaction. So this organization is so much important that it helps you as a student or a scholar of science to understand and predict the behavior of different elements in that period. Makes learning easier. Rather than when you find lithium is seen here, you are having again potassium is seen around where neon is, and that makes all the study very difficult. So we do know that around this the halogens are actually not the halogen specifically, but then these others that are in this group are seen to be inert. For example, argon, krypton, helium, and so on and so forth. So let's move into our next page that we are going to be looking at periodicity itself. What actually brought us here? What is periodicity? So a lot of students have been asking me and they have been telling me, yes, sir, there are very many attributes as far as the atomic properties of these elements are actually about, but then it makes it so difficult for me to understand the concept, and it is so a little bit challenging. So at the end of this video, a learner should be in position to summarize the explanation of electronegativity, electropositivity, ionization energy, atomic radius, as far as the trends are all concerned, in just a simple masterpiece explanation that I have for you. So please stay tuned and make sure that you are available to the very end of this video, because I'm going to disclose the concept, that the trick that is behind explaining all the periodic trends, be it be it metallic character, be it electronegativity, be it electron affinity, all of it. So when you look at what is periodicity, periodicity itself just refers to the repeating pattern specifically. Underline the concept that we're talking about. Just a repeating pattern of physical and chemical properties of elements when arranged according to increasing atomic number. So you realize that even the periodic table itself arranges the elements according to increasing atomic number. So when we studied the repeating pattern of physical and chemical properties, as we told you, or rather as we discussed earlier on, that we saw that when we study a specific group, you realize that there is something common in reactivity, be it with water, be it with oxygen, there is something similar about them. That's why they're categorized that way. So when we are talking about periodicity, it's just the same, just a repeating pattern of the physical and chemical properties that we're already discussing of elements when arranged according to increasing atomic number. And all of us know atomic number basically is just the number of protons in the nucleus of an atom. So these properties keep on repeating because of the fact that the arrangement of the electrons also repeats. That is something key for you to notice and rather take home. The arrangement of electrons also repeats. How do we see that? We do usually know that we are having, if that is the nucleus, we do know that we're having that, the first layer, then we're having the next, having the after the first energy level, the next energy level has about 8 electrons that can fill it, and so on continuously. So when we keep on moving, you realize that all the other energy levels, the maximum number of electrons that they can be taking up is 8. So that arrangement of the electrons around the nucleus of an atom in the energy levels makes the properties of that is basically the physical and chemical properties of the elements in specific groups to keep on repeating and all over again. So I hope someone has gotten the concept and understanding what periodicity is. So as far as periodicity is concerned, we are going to be looking at specifically the what literally causes the periodicity. What causes these properties to keep on occurring repeatedly. All right. So there are basically three properties that actually affect them, or rather affect periodicity. You can say cause periodicity to occur. The very first one of all of them is specifically what we call the nuclear charge. It is very simple and very easy to understand. Nuclear charge itself is just the total number of positive charges in the nucleus of an atom. All right. Or you can say it's just an equivalent of the protons. Since we say positive charges, and then you do know that in an atom there are only protons that are positively charged. The rest are either neutral or negatively charged. So that is what nuclear charge is. So understanding this specific concept enables us to know specifically how we can denote a nuclear charge to be Z, okay, to be Z, helps us to know how our periodicity is caused. Then the other one is what we call screening effect, or you can call it a shielding effect, depending. We can denote this as S. So specifically from the word screening effect, you realize that this screening effect is just a repulsion of the outermost electrons by those that are seen in the innermost sub-energy levels from nuclear attraction. For example, if we are having, this is our nucleus, we are having orbitals, okay? We're having energy levels around the nucleus. So the outermost electrons here are being repelled from nuclear attraction because there is actually a force that is pulling these electrons, the positive force inside, okay? The nuclear attraction. So we are having these electrons to be, they're actually supposed to be pulled because they're oppositely charged from the charge that is in the nucleus that we are having protons seen inside. But then this repulsion, the magnitude experienced of attraction to these electrons here is a little bit kind of lowered due to the fact that there is something more like a curtain that is seen around these electrons that are, it's formed something more like a barrier. These electrons that are in the innermost energy levels are kind of repelling the ones that are seen located outside here from a sufficient nuclear attraction. I hope that has been understood as far as screening effect is concerned. Then effective nuclear charge finally, which we can denote as specifically Z effective, alright? Z effective is just the net positive charge that is experienced by an electron in an atom. The net, meaning that this is actually a balance between, it's just a balance between specifically screening effect and effective, and nuclear charge. And nuclear charge. That is all I need you to know. Okay? All I need you to know. If it is a balance, then specifically what do we have? Screening effect, or rather, sorry, effective nuclear charge is just a balance of what we said, the nuclear charge, which is Z, and the screening effect, which you can denote as S. So if the nuclear charge is high and the screening effect is low, that means the net positive charge experienced by an electron in an atom will also increase, or rather the effective nuclear charge. But then if we're having a screening effect being higher than nuclear charge, meaning that even the total positive charge that is going to be experienced by an by an electron in an atom will also be lowered. I hope this point has gone home. So it's just a balance. It's how these different, how the nuclear charge and the screening effect actually contribute to the total magnitude of a force that is trying to pull, or rather attract, the electrons towards the nucleus of an atom. That is the effective nuclear charge. So it is basically these properties that are the ones that are causing the variation. It is these are the fundamental properties, and they are the ones that we are commonly going to be seeing appearing constantly as we are explaining the trends across the periodic table, or rather down across the periods and down the groups specifically. Because when we have a reaction supposed to take place, specifically if an electron is supposed to be removed from an atom, it has to, for an electron to be removed from an atom specifically, the fact that the charge that is trying to attract this electron towards the nucleus, that threshold has to be surpassed. That energy has to be surpassed. So we are supposed to be having the energy that is attracting the electron towards the nucleus being surpassed in order for this electron to be lost by the nuclear by the atom. All right. And all of that is actually contributed that for that to happen, evenly the screening effect contributes towards it, because screening effect itself is evenly preventing that attraction, the magnitude of attraction, to be sufficient enough for the electron to continuously be attracted towards the nucleus. So this shielding, or rather screening effect, is a little bit also trying to let go of this electron to be lost, because it is actually acting as a barrier, reducing the magnitude, the total magnitude of the force that was to be attracting the electron towards the nucleus of the atom. So all those properties are the ones that are counterbalanced here. All right, counterbalanced here. They're the ones that are actually seen counteracting each other, because specifically in different types of bonds, because you do remember that for a chemical reaction to occur, there must be cleavage and formation of new bonds. There must be fusion and fission occurring for a specific compound to be formed and reactions to occur. And all of those make the understanding that we have bond formation occurring. That involves bond cleavage and uh, bond cleavage itself, and also the bonds themselves being formed. So you realize that if we actually don't really have the electrons being lost, or rather being shared, specifically depending on the type of bond that is actually being formed, the electrons are so much key as far as chemical reactions are concerned. That's why we are studying the chemical properties, understanding reactivity. So all those variations are just so much involved into this periodicity. So that is something small as far as what we are going to do. We're actually going to look at specifically how all of these explanations are going to make sense by looking at the atomic properties. So the atomic properties that we normally are going to be looking at these specific points, I tried to list out a few. Those are many, but we are going to use a few examples to make sure that the point goes home. When you look at atomic radius, ionization energy, electron affinity, electronegativity, electropositivity, metallic character, and standard electrode potential, to mention but a few. So these are the few of some of the atomic properties that we're actually going to be looking at. So I want us to look at specifically how the effective nuclear charge, the nuclear charge, and also screening effect are causing these properties to vary in the periodic table, that is specifically across a period and down a group. All right, so let's look at one at a time. Let's first pick a few examples that we can be using specifically to explain trends. We can start with a trend specifically across a period. All right, across a period. So the very first things first, maybe we can start explaining the very one that involves atomic number, right? Atomic number. We can first start with the one that involves atomic number. This is our first atomic property that I would like us to be looking at, as far as not literally atomic number, but then it is atomic radius. All right, atomic radius. Let's look at atomic radius to be our first, okay, to be our first property that we are going to be looking at right now. Atomic radius. Now, for all of us, we do surely know that when we're having atomic radius, understanding that definition or rather what atomic radius is so much key before we fall into explain. So when we look at how, when we have two atoms, two similar atoms, all right, two similar atoms that are actually bonded together, specifically in a covalent bond, it is atomic radius is just the half the internuclear distance, okay? Internuclear distance. So you realize that this is R, this is R. So that specific distance that we're having is what we are calling that specific half internuclear distance that we're having between two atoms that are actually seen in a covalent bond. And this is actually in a diatomic molecule, all right? And the atoms have to be similar, like I said initially. So once you have understood, for now that you have understood that what atomic radius is, let's look at how atomic radius actually varies specifically. We are trying to look at these trends, how it varies specifically uh, across a period, all right? How atomic radius varies across a period. So let's maybe try looking at maybe period 3. We can't take short period 3 for now. Period 3. Okay. So I have not gotten some compiled data, but then here is something that you need to be understanding. I want us to build the understanding from the three attributes that we talked about. That is the nuclear charge, screening effect, and the effective nuclear charge. Effective nuclear charge. These are the attributes that I want us to base on to give our explanation. So when we look at specifically uh, across a period, we do realize that across a period we're having electrons being added. Okay, across a period we always have electrons that are actually added to each atom. Okay, element to element, specifically as we move. For example, when we see short period 3 from sodium to uh to chlorine specifically, let's put it to chlorine, let's not take it to the other final group. There is something that you need to be looking at currently. Okay, the electrons are actually added, but then the electrons from sodium to chlorine, electrons are added, okay, to the same energy level from atom to atom of the specific different elements. So you realize that if we are having electrons being added on the same energy level specifically, what do you see that actually happens to nuclear charge? Because when we say that something is an atom, meaning that it has the charge is literally neutral. That means if an electron is being added from atom to atom, subsequently a proton is also being added in the nucleus, because we are having the charge being net charge being 0. It is actually neutrally charged. An atom is neutrally charged. So that means that specifically the nuclear charge would be increasing. Nuclear charge increases specifically. All right, nuclear charge is seen to be increasing. Why? Because we're having the number of protons being added inside the nucleus as we move uh, across the period. Then the screening effect. Screening effect itself literally becomes almost constant, okay? Or it actually remains almost the same, okay? It is so prudent that the word almost appears. It actually becomes almost, okay? Almost remains constant. Constant. All right? Because we are having the electrons being added on the same energy level. Okay, so the curtain that we are seeing that is literally shielding the outermost electrons from nuclear attraction, the electrons that are seen in the innermost energy level, or rather the number of energy levels that are seen inside, are literally the same. They are the same across the period. So we find that it is literally almost the same screening effect that is experienced. So at the end of it all, we shall have the counterbalance, that is the effective nuclear charge screening, which is the balance of nuclear charge and screening effect. Since we are having this one increasing, that is nuclear charge, and screening effect almost being constant, what happens to the effective nuclear charge? You realize that the effective nuclear charge increases because we are having this one keeping on to increase, as this is always the same. That is the screening effect. So that means that our effective nuclear charge will always have to increase as we are moving from one element to the other, that is along or rather across a period specifically. So if we have effective nuclear charge increasing, so that means that if we're having now this is the nucleus, we are having the net charge that is attracting the electrons towards the nucleus increasing. What specifically now happens to the outermost electrons? You realize that these outermost electrons become so strongly and closely attracted towards the nucleus than they are actually repelled, because the net charge that is attracting is increasing across the period. Right? So at the end of it all, if the electrons are continuously being attracted or rather being pulled towards the nucleus from one element to another across a period, that means that the atomic radius will keep on decreasing. It will keep on decreasing because the electrons are confined more. The magnitude of the force that is trying to pull the electrons closer to the nucleus is a little bit is increasing in strength as we are moving across a period. As simple as that is. So that means that across a period, we shall be having specifically our atomic radius decreasing. Okay? Atomic radius decreases across a period. Decreases across a period. As simple as it is. Based on what? Based on the simple few attributes that we have been looking at. That is our nuclear charge screening effect and effective nuclear charge. Okay, if we were to look at another attribute here specifically, let's now we are done with the study of, we have understood how atomic radius actually is varying, that is specifically across a periodic table. So let's wipe off this screen, let's clear it off, and let's sample out ionization energy as our final atomic property that we are going to be using for that training here. That is, so as it has always been, understanding what specifically you're looking at makes a little bit of so much sense. So ask yourself, what is ionization energy? Okay? Ionization energy is just that energy that is basically required to remove an electron from a gaseous atom or ion to form a positively charged gaseous ion. Okay? But then it's not just the energy, but it has to be the minimum, the smallest energy that you require to remove an electron from an atom that is in gaseous form or an ion that is also seen in gaseous form to form a positively charged gaseous ion. Because once electron is removed from an atom, it forms an ion which is actually charged positively. Specifically, that is just understanding that that is actually a cation that is being formed. So without further ado, we are looking, since we have now understood that this is basically a minimum energy that we need to just remove. Let me draft this out, a drawing. The smallest energy required to remove just this electron. Okay, to remove this electron from this atom is what we are talking about currently. That is what ionization energy is. So having understood what ionization energy is, let's dive into understanding how this specific properties that is the effective nuclear charge, screening effect. We shall always be denoting them. We have the nuclear charge, screening effect, and we have the effective nuclear charge. Okay, so specifically we shall still consider our very elements that we have been looking at specifically. All right, we are going to be considering the same. Okay, this time around we can take any other. We are looking at literally across a period, so we can still take maybe period 2, any period. This explanations is valid for any period that you decide to be taking up. Okay, so for a period, what you need to be knowing still, we all know or rather have understood that when we are looking at a period, nuclear charge always will increase. Screening effect always will be seen to be almost constant. And that guarantees the effective nuclear charge to also increase. So at the end of it all, the force that is trying to attract the electrons towards the nucleus is literally going to increase. That is as far as the fact that effective nuclear charge is increasing across a period. I hope that has been understood. So with that simple understanding of how these three properties are actually varying across a period, when we now see as you're moving across a period, will the ionization energy increase or it will decrease? It is a simple question for the brain. The minimum amount of energy required to required to remove an atom from the from a gaseous atom or gaseous ion to form a positively charged gaseous ion. Will it increase or decrease? You realize that that energy that is required will actually generally increase. It will increase because as you're moving across a period, the effective nuclear charge that is pulling the electrons towards the nucleus has increased. So the amount of energy required to now act against the fact that when we are trying to remove an electron, we are now acting against the force that is trying to pull the electrons towards the nucleus. This energy will also be seen to increase. So as we are moving down or further, you realize that the beauty of explaining these different prospects becomes a little bit simplified and easier as long as you've understood what atomic property you're looking at. It makes everything very easy because these are the simple concepts that we are going to be dwelling on. So that is so much brief as far as the study of the trends across a periodic table is across a period is concerned. So let's dive in and look at maybe the trends that are seen that is now down a group. So since we consider the examples of ionization energy and atomic radius, maybe let's try taking up something different this time around. Maybe we can now look at electron affinity this time around. Understand what electron affinity is key. I've always told you people from our very first understanding this atomic property is what is important here. So atomic property it itself that we are looking at is what we call electron affinity. So you may be asking yourself what electron affinity is. Now electron affinity is just simply the amount of energy given out when an electron is added to a gaseous atom to form a uninegatively charged gaseous ion. This time round we are not removing an atom. Okay, it is more like the opposite of ionization energy. Here we are adding an electron. An electron is being added onto an atom which is in gaseous state. Okay, so since you have understood that here we are involving addition of an electron to an atom specifically, Now that calls for understanding now about our same different prospects. I'm always going to keep on writing them. This is nuclear charge screening effect and our effective nuclear charge. Okay, we are now looking at trends down a group. So we are going to first analyze how these are going to be varying. That is our effective nuclear charge. Also look at how screening effect and also how nuclear charge are varying. That's down a group. So down a group characteristic to it is the fact that when we're moving down a group, the number of energy levels keep on increasing. Okay, we are having an energy level fully filled with electrons being added to the element that is seen at the lower point down the group. So this is how it looks. So beautiful. So if we are to look at effective nuclear charge, not effective nuclear charge but specifically nuclear charge, the very fact that we are having this as atoms, meaning that however many the energy levels we are adding, as long as it's an atom, they come with those electrons. That means that even the number of protons in them will be added. Okay, as we're adding electrons, even the protons will be added. That means our nuclear charge increases. Screening effect, since we are having the number of energy levels also increasing down the group, meaning that the curtains that are actually being formed, I told people to understand this maybe as curtains that are shielding or rather preventing attraction of the outermost electrodes towards the nucleus. So even this screening effect will increase because we're having these curtains being many. I just in a layman understanding, let's look at them as curtains. There are being so many. Okay? There are being so many literally. So what happens to our effective nuclear charge? That is something that I need someone to look into and understand deeply as far as this is concerned. What happens to our effective nuclear charge? And not effect yeah, what happens to our effective nuclear charge? Okay? We are having this effective nuclear charge. We have nuclear charge and screening effect. Both of these are increasing. But then the magnitude of screening effect here is going to be quite higher than that of the nuclear charge. Okay? Because we are having a little bit of so many electrons that are seen around, because there are over 8 electrons that are seen in each energy level being added from atom to atom down a group. So the repulsion is going to be so much higher as compared to where we're having protons being confined in a specific one location, that is the nucleus. So we see to it that we are going to be having our screening effect outweighing. The word outweighs matters. Outweighs. Okay? Outweighs the nuclear charge. So if screening effect outweighs the nuclear charge, ask yourself what happens to our final product. What happens to effective nuclear charge? That means that our effective nuclear charge is going to be seen decreasing here specifically. The trend down a group will be seen decreasing. All right. Now, since the effective nuclear charge has decreased, having understood all those different prospects, what specifically will happen to the electron affinity, which is the amount of energy, okay, the amount of energy specifically that we do need, okay, the amount of energy that is literally given out when an electron is being added. So you realize that if the effective nuclear charge has decreased, what has to run into your brain is 1. Okay? Let me draw our atom here. Okay? Let me draw our atom there. So having understood that effective nuclear charge decreases, so what falls in your brain is that we are having the atomic radius, it itself going to increase. And it's even already seen here, it increases. Okay? So once atomic radius increases, so as we're adding this electron to this, if you just see to it that we are just going to be having the amount of energy that is actually going to be released by upon addition of the electron will be so much small. So if that our electron affinity now here will also be seen to be decreasing. Okay, it decreases. Our electron affinity decreases, as simple as it is in understanding, because we are having our atomic radius increasing. Okay, so that means even the electrons that are incoming, that are trying to be added here, are actually very far from the nucleus. So if they're far from the nucleus, that means that even the nuclear attraction is going to be so low. So the amount of energy that will be given off upon this attraction occurring will be small, because even the force that is trying to pull this electron towards this, let's just say maybe this nucleus is more like a magnet. I want the learners to look at it like that. The nucleus is more like a magnet that is pulling electrons. But then we are having a many energy levels being seen around here, because we are now having atomic radius increasing. So the tendency of this being pulled towards this will actually be low. So that means the energy that will be given out upon attraction will be so small. That is down a group. So that means our electron affinity will decrease, as simple as it is. That is one of our atomic properties that we have looked at. There are so many atomic properties to be looking at. Okay, so many. Maybe to sample another one, electronegativity. Understanding what electronegativity is will just make you understand everything finally. Like I've always told you, that these are the same things that we're going to be using for explanation as far as nuclear charge, screening effect, and effective nuclear charge are concerned. Okay, we all know that down a group we are having nuclear charge increasing, screening effect also increases, but then effective nuclear charge will actually be seen decreasing, not increasing. This will be seen decreasing because due to the fact that our screening effect will always outweigh our nuclear charge down the group based on whatever we have explained. But then understanding what electronegativity is will help us solve the matter. Electronegativity is simply a behavior or rather a tendency of an atom to always attract the bonding electrons towards itself in a covalent bond. It is this electronegativity that actually enhances polarity between a bond or rather in a molecule to be prominent, depending if we are having one atom here, another atom here covalently bonded. So atom A, atom B. If atom A attracts the electrons towards itself more, that means that atom A is more electronegative, because we have already understood that it's just a tendency of an atom to attract the bonding electrons towards itself, because these are the electrons that are literally involved in the bond. Okay, in the bond here. If also we have here A and B, and B is more electronegative, meaning that for it to be having electrons more attracted to it than A, and that will be giving it a partial negative charge as A is getting a partial positive charge, and here A will be having a partial negative charge and B will be having a partial positive. This is actually now bringing us to a concept that is polarity that we shall be looking at in some other different topic. But then for now, let's first understand. Having understood what electronegativity is, let's now dive in and see to it that we can harmonize this work as far as electronegativity is concerned, using our simple explanations that we have always been having there. Okay, simple explanations as we have always been having there. So since we have understood that always nuclear charge increases down a group because we are having protons that are being added from atom to atom. Screening effect also increases because we are having an energy level fully filled with electrons being added from element to element down the group, and effective nuclear charge decreasing because we are having our screening effect or shielding effect outweighing the nuclear charge like we explained earlier. So what happens when we are now looking at a group? Since we know all those attributes and we have understood electronegativity, what happens to it is now from this effective nuclear charge that we should look at things, because we are now having the fact that if effective nuclear charge decreases, that means even the force attracting the electrons towards the nucleus has decreased. So our atomic radius will keep on increasing. Okay? Atomic radius will keep on increasing. Literally, if initially we had our atom being very small like this in atomic radius, the atomic radius will increase because we are having the electrons, or rather being weakly attracted, and they are far away, so they are weakly attracted towards the nucleus, meaning that our atomic radius will increase. So that means that our bonding electrons, or rather the electrons that are being used in formation of the bond, like we are seeing A and B here, the electrons that were being used to form the bond itself, they will actually experience what we call a greater repulsion than nuclear attraction, because we are having always the electrons that are being used in formation of bonds and the electrons that are seen outside. So if we are having the electron being very far away from the nucleus like it is here in this atom, this atomic radius is so much big as far as this one is concerned. With the electron, it is so small. So if this is actually a little bit so big, that means that this electron is actually experiencing so much of a less attraction to the nucleus and experiencing greater repulsion due to the fact that the screening effect is so much increased. Okay, so that means that this electron here rather will be seen to easily donate the electron for formation of a covalent bond. Okay, formation of a covalent bond. So this is it. As we are moving very, very far away, you realize that our electronegativity actually will be seen to decrease. Because here, if the electron is actually very small, meaning that it is experiencing so much attraction to the nucleus. Okay? It is experiencing, this is atom A, this is B. Okay? It's experiencing so much attraction to the nucleus. So meaning that at the end of it all, in order for it to be attracting another from another atom that is actually of a different electronegativity, or rather having a large atomic radius, you find that it easily attracts this, meaning that the tendency will be higher in A. But then when you look at B, which is seen at down the group, it is having large atomic radius, meaning that these electrons here is loosely attracted towards the nucleus and is also experiencing a repulsion. So however much we are trying to form a bond, there will be literally no tendency of the electron that is formed here, the electron that is actually being donated for formation of a bond between B and another atom, maybe X here. This energy that is actually being used to attract this electron to this is so much low. Is so much low. So meaning that electronegativity will actually be seen to decrease from atom to atom, specifically down a group. As simple as that is. So that is my final verdict as far as the trends down a group and across a period are. This is now where I want all eyes to be tuned at. This is our master explanation. Very first thing in our master explanation that you notice that everything that we talked about was relying on how our nuclear charge and screening effect are bringing about effective nuclear charge, causing variation in atomic radius, okay, to occur and the different properties. So be it effective nuclear charge, electropositivity, electronegativity, metallic character, atomic radius, all of them will always follow this explanation that we are giving right now. Always our paragraph 1 will be a paragraph that deals with our effective nuclear charge. Paragraph 2 will always talk about effective nuclear charge, screening effect. Paragraph 3 will always be having our effective nuclear charge. And also, our final paragraph will be a conclusion. A conclusion. What has happened to atomic radius? And now what has finally happened to the atomic property that you're looking at? So it is so important that you are supposed to always describe. By describing, you're supposed to tell us what has happened to the atomic property you're looking at. What has happened to atomic radius? Has it increased or decreased? After describing, now come and give us our first paragraph as far as explanation is concerned. Tell us that paragraph 1, for example, if we're looking at a group, we all do know that when we're looking at a group, what happens to this all these different attributes? Then when we're looking at a period, what happens to them? Okay. So when we're looking at a group, one of the things you realize that in a group, our nuclear charge increases because we're having the protons that are also being added to the nucleus. Effective nuclear charge also increases due to the fact that we're having an energy level completely or rather fully filled with electrons being added from element to element. Effective nuclear charge is seen to decrease. Why? Because we are now having the screening effect outweighing nuclear charge. Always, that is for a group. That is the understanding. For any group that you'll be seeing. So now, with all the knowledge that you have understood in that summary, what are you looking at? Is it electronegativity? Do you know what electronegativity is? Once you know what the different atomic property you're trying to talk about is, even without being given a table of data to analyze, you can be in position to give a conclusion, a fair judgment, okay? A fair judgment that is suiting what you're looking at. Since you now know the definition, you have understood the definition of each atomic property, you know each offhand, and then you can relate using these three basic aspects that we're actually looking at. That is always what you're supposed to look at. For a period, we always know that for a period we have the screening, we have the nuclear charge increasing, screening effect becomes almost constant, and we are having effective nuclear charge increasing based on the explanations that we gave. Nuclear charge that is in a period is seen increasing because we are having protons being added to the nucleus. Screening effect becomes almost constant because the electrons are being added on the same energy level. Effective nuclear charge increases because we already see that we are having the nuclear charge increasing, that is across a period. So look at the atomic property you're looking at. Do you know it? Have you understood it? Can you explain it using that different understanding? Using the work that we have given here. So at the end of it all the marks will be awarded to a learner that has explained properly by first things first. Let me wipe this off since we have understood this. So this is how your work is supposed to look as far as the description is concerned. The first statement you're supposed to give is a description of the atomic property. Does it increase or it decreases? You're talking about nuclear, electronegativity, electron affinity, electropositivity, and so on and so forth. Then paragraph 1, having described, will always be about our nuclear charge. Paragraph 2, state the nuclear charge. What happens to it? Has it increased? And tell us why it increases. Because it's always the same. Decrease, tell us why is it decreasing? Because it's always the same. Come to our paragraph 2 that will always be talking about our screening effect. Tell us, is it almost constant or is it specifically increasing? And we gave reasons for all of that. Why is it almost constant? Electrons are being added on the same energy level. Why is it increasing? Because we are having an energy level fully filled with electrons being added. I hope that has been understood. Then our paragraph 3, you tell us now what has happened to effective nuclear charge. Okay? Tell us now what has happened to effective nuclear charge is what the examiner needs to know. What has happened to effective nuclear charge? Based on the fact that you've understood this, analyzed this, explained it. So after our paragraph 4 will always be a conclusion. Conclude, make a fair judgment, recommend. So always that will be the way you will be explaining all the atomic properties that we have explained and the ones that I have not explained. That will always be how I expect you to always explain them. So with all that we have looked at, let's see this. The real world applications of periodicity. That is what I want us to look at. Periodicity itself is a little bit so interesting. Periodicity, it is seen being applied in the world of medicine, in the world of engineering, and so many other places. For example, when you're looking at the study of medicine itself, as medicine is being designed specifically, scientists actually use these periodic trends like the atomic size, ion formation, and the reactivity differently to actually select the elements that can be used for medical treatment. Okay, for example, when you see the radioactive elements like technetium 99M, that's actually being used in medical imaging. You see that? Because the atomic properties are predictable from their position in the periodic table, you can easily know that this is radioactive. Things like calcium, iron, iodine, they actually play so much important role in the body processes that happen in your life. Muscle contraction, so much seen calcium. Iron seen in hemoglobin. Okay, zinc is so much important to your body. So all of this you realize that periodicity is not just being studied for you to pass an exam, but is important in real life application. Okay, when you see the batteries, for example, in batteries you realize, especially maybe the phone batteries, we normally use lithium because it is rechargeable. Okay, and lithium is seen in group 1. So it's because of the how reactive the element is in that specific group and it is positioned in the group is why it is chosen. And all of that you've understood from the study of periodicity. You've studied it from the periodic table. Look at the semiconductors. Semiconductors basically are just materials that conduct electricity, okay? Specifically, this is in different controlled conditions. So in order for a material to be selected, when you're selecting, you're trying to compare between aluminium maybe and copper for transmission of electricity, be it silicon. Okay, you are trying to look at a specific element that you're trying to choose. You're supposed to study its reactivity chemically. You're supposed to know its physical properties, that is in terms of conductivity. That is how these specific elements like germanium can be selected for a choice of an element to use for electrical conductivity. Okay, so sciences can also add small amounts of other elements to modify the reactivity of this specific element. Okay, maybe form something better of that same element, but in addition of another element. That is deeply understanding alloys. And also in the formation of fertilizers. Okay, fertilizers specifically like phosphorus, nitrogen, potassium. These ones are nutrients basically needed by plants. Okay. And for example, when you see the reason as to why an element, for example, we can see potassium. Potassium is actually highly soluble and can easily be absorbed by a plant. Okay. And that is because it is in group 1. That is a property of group 1 elements. All of them are literally so soluble in water. So having the knowledge that they are soluble in water enables you understand that yes, it dissolves so easily absorbed since it is in solution form now, taken up by the plant and utilized. Okay, having the knowledge of the chemical behavior of the different elements helps this specific fertilizer manufacturers to produce fertilizers that actually release nutrients efficiently and improve crop yield. So it is so much important for you to have this knowledge of periodicity. It is so much important. It is this periodicity, that understanding of how these pharmacists make the medicine, how the carbonates, the elements that are in the carbonates are actually brought about to be used. Why isn't it not that we are using copper in a car battery, but we are using lithium? It is because of the chemical property that is actually seen varying depending. And all of that is contributed due to the fact that you now understand periodicity it itself. Then, as I conclude, you now see to it that in conclusion, the periodic table itself is not just in a chart that you're going to be having there to memorize. It is the chemistry behind that chart. It is actually a story of how nuclear charge, screening effect, and electron arrangement shape the behavior of every element. How an element is behaving the way it is because of the fundamental of how the nuclear charge is brought about, screening effect, and finally, the balance between them, that is the effective nuclear charge, is going to be contributing fundamentally to its physical properties, its shape, its chemical properties. So we don't just, it is not just because they are arranged due to increasing atomic number. This chart is the chemistry behind everything that you're going to be looking at. The fundamental of chemistry is understanding reactivity of elements as far as inorganic chemistry is concerned. So just understand the cause of periodicity. If you understand that periodicity is caused by nuclear charge, screening effect, and specifically the counterbalance, which is effective nuclear charge, and electron arrangement, that is specifically when we are to look at our electronic configuration. Okay? Electronic configuration. Normally, I like to abbreviate it as EC. So having understood with fair judgment, as we have explained above, how all of this actually cause periodicity, the chemistry will always start making sense to you. Inorganic chemistry will always keep on making sense to you. So I am so happy that everyone has been positioned to understand something from this video, and it's my pleasure, and I'm so grateful that you are in position to watch till this very end. And please don't forget to follow our YouTube channel. Okay. Also, like, share, and comment. And I will be in position to reply to all the comments that will be posted below. I love you so much, and I will be seeing people in our next video. The Universe Science Scholars Academy, USSA. Let's explore the universe together. I remain Master.